Hey, I'm Lauren Schaefer, and today I want to talk to you about how you can quickly get started using Node.js and MongoDB together. So if you're familiar with Node.js and you're new to MongoDB, this is the video for you. So today I'm going to walk you through how to quickly get connected to a MongoDB database and how to perform each of the 4 CRUD operations: create, read, update, and delete. Now, if you happen to stumble upon this video, but you're really more of a fan of text-based tutorials, don't worry, I've got you covered. I will drop a link below to a blog series I wrote that covers the exact same content. So without further ado, let's jump on in. Let's talk about what you need to get set up before working on getting connected to your database. The first thing you'll want to do is install the code editor of your choice. Today I'll be using Visual Studio Code, but you can use whatever code editor you'd like. Next, you want to double check that you have a supported version of Node.js installed. You can check what version you're running by executing node-v. As you can see, I'm running version 10.16.3. The next thing you'll want to do is install the MongoDB Node.js driver. So the driver allows you to easily interact with MongoDB databases from within Node.js applications. You'll need the driver in order to connect to your database and execute the queries shown in this video. So if you don't have the MongoDB Node.js driver installed, you can install it by running npm install MongoDB. As you can see, I'm running version 3.3.3 of the driver. If you already have the driver installed and you just want to check what version you're running, you can execute npm list MongoDB. All right, the last thing you're going to need is a MongoDB database. Now, your database is going to be stored inside of a cluster. At a high level, you can think of a cluster as a set of nodes where copies of your database will be stored. Now, the easiest way to get started with MongoDB is to use MongoDB Atlas. MongoDB Atlas is MongoDB's fully managed database as a service. If you haven't used it before, I will drop a link below. So head on over to Atlas, create a new cluster, and you can use a free tier. Once your tier is created, you're going to want to load the sample data set. Now, if you're not familiar with how to create a new cluster or load the sample data set, my friend Max created a fantastic video that walks you through this step by step. So once again, I'm going to drop a link below. Now that everything is set up, it is time to code. So let's write a Node.js script that connects to our database. So let's jump back to our code editor and create a new file named tutorial.js. The first thing we want to do in our file is import the Mongo client. The MongoDB module exports Mongo client, and that's what we're going to use to connect to a MongoDB database. As you'll see, we can use an instance of Mongo client to connect to a cluster, access the database in that cluster, and close the connection to that cluster. So let's kick things off by creating an asynchronous function called main. We'll use our main function to connect to our cluster, call functions that query our database, and then disconnect from our cluster. So the first thing we need to do inside of main is create a constant for our connection URI. So I'll say constant URI equals empty string. Now, what are we going to put in here? Let's head back to Atlas, and let's click this connect button. So here we get a handy wizard that's going to walk me through step by step what I need to do to connect to this cluster. So the first thing it asks me to do is whitelist my connection IP address. So I'm going to click add your current IP address, and then once again click add IP address. Next, I'm going to create a MongoDB user that I will grant access to this cluster. So I'll name this user Lauren, and I'll input a password and click create MongoDB user. Now I'm ready to click choose a connection method. So here I'll choose connect your application. For the driver, I'm going to select Node.js, and for the version, I'll select 3.0 or later. Now I'm going to copy this connection string. I'm going to head back to my code editor. I'm going to paste this inside of my URI. Now you'll notice when you paste this in, there's a space for you to input the password, and this is the password for the user you just created in that connection wizard. This is not your Atlas password. So I will input my password for that user and save the file. Now that I have my URI, I'm ready to create an instance of Mongo client. So I'll say constant client equals new Mongo client, and I will pass in that URI. Now the URI is the only thing you need to pass when you create a new Mongo client. However, at the time of this recording, there are a few options I need to pass in order to get rid of some ugly deprecation warnings. These are just warnings, so if you see them, they're totally fine. But just so that we aren't looking at them here today, I'm going to go ahead and pass these options. Now we're ready to use our new Mongo client in order to connect to our cluster. And we can do that by calling client.connect. Now client.connect will return a promise. So I'm going to use the await keyword to indicate that we should block further execution until that operation has completed. Ideally, nothing's going to go wrong here, but just in case, let's put this inside of a try catch. And we'll just print out any errors that we get. And after we connect, we want to make sure we close that connection. So let's put that in a finally statement. So we'll say finally client.close. Again, this will return a promise. So we'll use that await keyword to indicate that we should wait for that connection to close before continuing on. Last thing we'll do here is actually call this main function. So we'll say main, and just in case we get any errors, we'll say catch console.error. All right, let's run this and see what happens. So we'll say node tutorial.js. Okay, so nothing happened here, but that's good. What happened is we successfully connected to our cluster, and then we closed that connection. So let's actually do something to prove that our connection is working. Let's list the databases in our cluster. Let's create an asynchronous function called list databases. So what we want to do in this function is use our Mongo client to access the admin database and list the databases. So let's use the client as a parameter here. Let's create a constant called databases list, and we'll get that from calling client.database. Let's access the admin database and call the list databases function. This is an asynchronous function, so let's use that handy await keyword. So now that we've got our databases list, let's print it out. So we'll say console.log databases, and then we'll say in that databases list, let's access the databases, and for each one, we'll name the database DB, and we'll call an arrow function that will just log the name of the database. All right, let's save it. Now we need to just call this list databases function. So we're going to call that from inside of our main. After we've connected to our client, let's call list databases, and we will pass our client. I'm going to save the file. And let's try executing tutorial.js again. Here we can see a list of our databases, so we can tell we really are successfully connected to our cluster. Before we go any further, let's take a moment to talk about how MongoDB stores data. So I've opened Atlas in my browser, and I've navigated to the collections pane. Now MongoDB stores data in BSON documents. BSON is a binary representation of JSON documents. JSON standing for JavaScript Object Notation. Now, when you start reading MongoDB documentation, you'll frequently see the term document, but you can think of a document as simply a JavaScript object. For those coming from the SQL world, you can think of a document as being roughly equivalent to a row. So if I scroll a bit here, you'll see a document representing a specific Airbnb listing. Now, MongoDB stores groups of documents in collections. In this case, our collection is called listings and reviews. For those with a SQL background, you can think of a collection as being roughly equivalent to a table. MongoDB stores groups of collections in databases. So the name of our database in this case is sample_Airbnb. Now let's take a closer look at this Airbnb listing. As you can see on the left, we've got fields, and on the right, we have field values. Now I'm not going to go in depth here into what those field values can look like, but you've got a lot of options, a lot of flexibility in how you want to model your data. One thing I am going to point out is that every document is required to have a field named _ID. The value of _ID must be unique for each document in a collection. MongoDB will automatically create an index on the _ID field for you. So you can choose to make the value of _ID meaningful if you happen to have a unique value for each document that you like to be able to quickly search since you get a free index on it, or you can use a somewhat random object ID. And you'll see object IDs in just a moment when we jump into the Create section. MongoDB University has a fantastic course all about how to successfully model your data, so I'm not going to get into the details here. Let's jump right in. Let's talk about how to create a document. Let's begin by creating a new Airbnb listing. I've navigated to the Node.js MongoDB driver documentation, and I've opened up the documentation for the collection API. In order to insert a document, we're going to use the insertOne function. As you can see here, insertOne inserts a single document into MongoDB. InsertOne has one required field, which is the document to insert. Now, if you'll recall, every document inside of MongoDB is required to have a field named _ID. If the document that you pass to insertOne does not include the _ID field, the driver will take care of it and add it for you. So let's jump back to our code editor and create a function to create a new Airbnb listing. Let's make this an asynchronous function, and we'll call it create listing. We're going to want two function parameters here. We're going to want the client, and we're also going to want the new listing. And this will be a document that we will send to MongoDB to insert. So let's create our listing. So we'll say client.database, access our database named sample Airbnb. We'll access our collection called listings and reviews. And then we'll call that insertOne function that we just looked at, and we'll pass our new listing. Now we want to wait for the results to come back before continuing on, so we'll add that await keyword. And let's assign our results to a constant called result. Now technically this would be good enough. I like to add a little logging just so we can clarify what's happening. So let's just log our results. Now that we've got our function created, let's call it. So I'm going to remove this list databases call that we made earlier, and we're going to call create listing. So remember, create listing has two parameters we need to send. So first we'll send over the client. Then we also need to send over a new object representing our listing. We can send over as little or as much information as we'd like about our listing. So let's say we know the name of it is Lovely Loft. Its summary should be a charming loft in Paris. And it should have 1 bedroom and 1 bathroom. Let's save this and run it and see what happens. So there's a lot of output here. Feel free to scroll through it, explore it, see what you can find. What I find most helpful is to know the ID of the document we just inserted. So let's go update our create listing function. So instead of printing out the whole result, let's just print out the inserted ID. So we can say new listing created with the following ID, and we'll send over result.insertedID. So let's save that, and let's run this command again. Okay, so that's a little nicer. So now we're just getting the output that says new listing created with the following ID, 5DC, yada, yada, yada. So notice that since we did not include a field named _ID in the document, the MongoDB driver automatically created an ID for us, which is pretty handy. Now, if you're trying this for yourself at home, the ID of the document you create will be different from the one shown above. Sometimes you're going to want to insert more than one document at a time. You could choose to repeatedly call insertOne. The problem is that, depending on how you structured your code, you may end up waiting for each insert operation to return before beginning the next, which could result in some really slow code. So let's head back to the driver API. In addition to insertOne, collection also has a function called insertMany. insertMany will insert an array of documents into your collection. insertMany has one required parameter, and that's an array of documents to insert. I want to point out one optional setting that's kind of important. It's called ordered. By default, ordered is set to true. When ordered is set to true, the documents will be inserted in the order given in the array. If any of the inserts fail, for example, maybe you're attempting to insert a document with an _ID that is already being used by another document in the collection, the remaining documents will not be inserted. If ordered is set to false, which again, that is not the default, the documents may not be inserted in the order given in the array. MongoDB will attempt to insert all of the documents in the given array, regardless of whether any of the other inserts fail. So keep this option in mind whenever you use insertMany. You may want to set ordered to false, depending on what your use case requires. Okay, so let's try out insertMany. Let's write a function to create multiple Airbnb listings. I'm going to jump back over to my code editor, and I'm going to create a new asynchronous function called create multiple listings. We're going to need two parameters for this function. Just like create listing, we want the client to be a parameter, and then we want an array of new listings. So let's insert these new listings. So we can call client.database sample Airbnb. So we've got our database. Let's access the collection inside of that database called listings and reviews. And then let's call that insertMany function we just took a look at and send over that array of new listings. We want to wait to continue on with our function till we get those results back, so we'll use the await keyword. And let's assign those results to a constant called result. Now we want to print out our results. So there is a lot of information that's going to come back from these results, just like we saw with insertOne. So let's cut to the chase. Let's just print out how many documents were actually inserted. So we can say console.log results.inserted count new listing or listings created with the following IDs. And let's print out those IDs. So we'll say console.log results.inserted IDs. So let's try out calling this function. So I'm going to go back up to our main function. Let's remove this call to create listing and replace it with a call to create multiple listings. I'm going to paste this in so you don't have to watch me type all these out. But what I'm doing here is I'm calling create multiple listings, passing the client, and then I'm sending over an array of 3 new objects, 3 new Airbnb listings. So you can see we have a new listing called Infinite Views, a new listing called Private Room in London, and a new listing called Beautiful Beach House. One thing I'll call out here is that not every document has the same fields, and in MongoDB that's perfectly okay. Now, for those of you who are coming from the SQL world, you're probably going to find this incredibly uncomfortable, but I promise it really is going to be okay. When you use MongoDB, you get a lot of flexibility in how to structure your documents. If you later decide you want to add schema validation rules so you can guarantee your documents have a particular structure, you can. Okay, so let's save this file and run it. Let me open my terminal back up and let's execute this file again. So here we can see 3 new listings were created and we've got a list of their IDs. Just like the MongoDB driver automatically created the _ID field for us when we called insertOne, The driver has once again created the underscore ID field for us when we called insertMany. So we've now used the collection API's insertOne and insertMany functions in order to insert 4 new documents into our collection. So now let's talk about how to read documents out of our collection. Let's begin by querying for an Airbnb listing in the Listings and Reviews collection by name. We can query for a document by calling findOne. findOne will return the first document that matches the given query. Even if more than one document matches the query, only one document will be returned. findOne has only one required parameter, a query of type object. The query object can contain 0 or more properties that MongoDB will use to find a document in the collection. If you want to query all documents in a collection without narrowing your results in any way, you can simply send an empty object. Let's jump back to our code editor and start creating a function to find a listing by name. So once again, this will be an asynchronous function, and let's call it findOneListing by name. This function will have 2 parameters. First, it will have the MongoDB client, and then it will have the name of the listing. So what we want to do is call collections findOne function. So we can call client.database, access our sample Airbnb database, access our collection named Listings and Review, which lives inside of that Airbnb database, and then we'll call findOne. Here's where we're going to include our query parameters. So we'll say name is equal to name of listing. If we jump back to the beginning of this line, findOne is going to send us a promise, so we'll use our await keyword. And let's store these results in a constant called result. Now we could be done here, but let's print out the results. So let's do one thing if we get results and another thing if we don't. So we'll say if we get results, do this. Otherwise, do this. All right, so if we get results, what do we want to do? Well, we want to log that we found a result. So we'll say console.log found a listing in the collection with the name of listing. And then let's actually print out the document we found. So we'll say console.log result. Now, if for some reason we can't find a document in our collection with the given name, let's print that out as well. So we'll say console.log no listings found with the name of listing. And let's save that. All right, let's try out this function. So I'm going to head back up to my main function. I'm going to delete our previous call to create many listings. We're done with that. And instead, let's call this new function. So we'll say await find one listing by name. We'll pass over our client. And then let's search for a document we just created a minute ago called infinite views. Now let's open our terminal, cross our fingers, and run the script. All right, it worked. So we found a listing in the collection with the name infinite views, and here you can see the document. Note if you're running this yourself, the underscore ID that you get back is going to be different. That is correct. That's totally expected. One other thing I want to point out. We're calling findOne using the name field, and the name field is not guaranteed to be unique. So it's possible that more than one listing could have the name you provide here, but you're still only going to get one listing returned. Now that you know how to query for one document, let's discuss how to query for multiple documents at a time. So let's head back to the official documentation, and you can see here there's a function called find. Similar to findOne, the first parameter for find is the query object. You can send 0 to many properties inside the query object. Let's say we want to search for all Airbnb listings that have minimum numbers of bedrooms and bathrooms. So we can use the find function to do that. So let's head back to our code editor and create a new asynchronous function called find listings with minimum bedrooms, bathrooms, and most recent reviews. Let's talk about function parameters. As always, we'll have a Mongo client called client. And we've got a lot of parameters we need to pass here. So let's use destructuring. So we want to set a minimum number of bedrooms. We'll set the default value there to 0. A minimum number of bathrooms. Again, we'll set the default to 0. And finally, the maximum number of results. And we'll set that to numbers, max safe integer. Let's start building our query. We know we want to use the find function. So we'll call client.database, access our sample Airbnb database. We want to access the listings and review collection that's inside of that database. And we'll call .find. Now inside of find is where we can pass our query parameters. So let's start out with our bedrooms. We know that we want to have at least as many bedrooms as are in that minimum number of bedrooms parameter. So we'll say bedrooms where they are greater than or equal to that minimum number of bedrooms. We want to do something very similar for bathrooms. So we'll say bathrooms where the number is greater than or equal to the minimum number of bathrooms. So as you can see here, we're leveraging the greater than or equal to comparison query operator to search for documents that have bedrooms greater than or equal to a given number. And we're doing the same thing to satisfy our minimum number of bathrooms requirement. MongoDB provides a variety of other comparison query operators that you can utilize in your queries. So check out the official documentation for a complete list of comparison query operators. Now this query is going to return a cursor. So let's create a constant named cursor and set it equal to our query. Now a cursor allows traversal over the result set of a query. You can also use cursor's functions to modify what documents are included in the results. For example, let's say we want to sort our results so that those with the most recent reviews are returned first. We could use cursor's sort function to sort the results using the last review field. So I'm just going to chain a function here. We'll call .sort. We'll indicate the field we want to sort on is last review. And then we'll use -1 here to indicate that we are going to sort in descending order, meaning that listings with the most recent reviews should be returned first. If we were to execute this query, we would get over 100 documents in our results. So let's say we don't want to process that many results inside of our script. Instead, we want to limit our results to a smaller number of documents. So we can chain another function here. We can use .limit. .limit requires us to pass a number, the number of documents we want to limit our results to. So we'll pass our maximum number of results here. Now we could use our cursor to iterate over our results one by one. Instead, if we want to retrieve all of our results in an array, we can call cursor's toArray function. So let's do that. We can call cursor.toArray. ToArray will return a promise, so we'll add an await here. And let's store those results in a constant called results. Now ToArray does have the potential to send back a lot of results that could take up a lot of memory. We're safe here because we're using the limit function, so just be sure if you're using ToArray, you've got a manageable number of results. So now we've got our query structured and we're storing our results in an array. Let's print them out. So I'm just going to paste in the code that prints out the results because it's not that interesting. But basically what we're doing here is checking if our results.length is greater than 0, meaning checking to see that we actually have results. If we do, printing out that we've found some results. And then we're going to iterate over the results. So for each result in our results array, we're going to print out some information about it. We'll print out the name, the ID, the bedrooms, the bathrooms, and the most recent review date. So now we're ready to call this function. So let's head back up to the top in our main function. And instead of calling findOneListing by name, let's call find listings with minimum bedrooms, bathrooms, and most recent reviews. So we'll pass a client, and then we'll set the minimum number of bedrooms to 4, the minimum number of bathrooms to 2, and the maximum number of results to 5. So let's save that, and then let's run it. All right, and here we can see we did get 5 results. Here are listings with 4 bedrooms and 2 bathrooms, and they are sorted in descending order with most recent reviews first. So we can see at the top here, we've got a beautiful beach house with 4 bedrooms, 2.5 bathrooms that was most recently reviewed November 11th, 2019. So now you know the basics of how to find one document as well as how to find many documents. So now that we know how to create documents and read them, let's talk about the next of the CRUD operations, update. The collection API has a function called updateOne. UpdateOne has 2 required parameters. First, there's a filter of type object. The filter is used to select the document to update. Now you can think of the filter as essentially the same as the query param we used just a moment ago in findOne to search for a particular document. You can include 0 properties in the filter to search for all documents in the collection, or you can include 1 or more properties to narrow your search. The second required parameter is an update of type object, and this object contains the update operations to be applied to the document. MongoDB has a variety of update operators you can use, such as $increment, $current date, $set, and $unset, among others. So check out the official documentation for a complete list of update operators and their descriptions. UpdateOne will update the first document that matches the given query. Even if more than one document matches the query, only one document will be updated. So let's say we want to update an Airbnb listing with a particular name. We can use updateOne to achieve this. So let's head back to our code editor, and let's create a new asynchronous function called updateListingByName. We're going to have 3 parameters here. So as always, we'll pass a Mongo client. We're going to pass the name of the listing to indicate what document we want to update. And then we're going to pass the updated listing. So we know we want to use collections updateOne function. So let's go ahead and access that. So we'll say client.db sample Airbnb.collection listings and reviews, and we'll call updateOne. So remember, we've got 2 parameters we need to send here. So first up, we need to send our filter. We want to search for our document by name. So we'll say we want to update the document where the name is equal to our name of listing param. Now we need to indicate what we want to update. So we're going to use the set operator and pass the updated listing. The set update operator will set new values for new or existing fields in the document we are updating. When we use set, we pass a document that contains fields and values that should be updated or created. The document that we pass to set will not replace the existing document. Any fields that are part of the original document but not part of the document we pass to set will remain as they are. Now updateOne is going to pass us back a promise, so we're going to use the await keyword. And let's store these results in a constant called result. Once we get these results back, we need to log them. So we'll say console.log. There's a lot of information that comes back in the results. So first, let's say how many documents matched our query criteria. So we'll say result.matchedCount. documents matched the query criteria. And then let's indicate how many documents were actually updated. And since we're using updateOne, we should always get a 0 or a 1 here. So we'll say console.log result.modified count documents were updated. So I'm going to save this. All right, so let's say we want to update our Airbnb listing that has the name Infinite Views that I created just a few minutes ago. Let's head back up to our main function. And let's get rid of this find listings with minimum bedrooms, bathrooms call. And let's start out by getting a copy of the current Infinite Views listing. So we'll say await find listing by name. We'll pass the client and then the name of the listing, which is Infinite Views. Now let's call our function that will make the update. So we can say await update listing by name. We'll pass our client, the name of our listing, which is Infinite Views, and then our updated listing. So let's just say we want to update the number of bedrooms to be 6 and the number of beds to be 8. And finally, let's make sure that update went through. So we'll once again call await find one listing by name, client, Infinite Views. So let's save that. Let's come down to our terminal and try it out. Let me expand the terminal so we can look at this a little better. So here we can see we found a listing in the collection with the name Infinite Views. Initially, the number of bedrooms is set to 5 and the number of beds is set to 5. Then we can see we tried to update the document. So one document matched the query criteria and one document was updated. And then when we go to check the listing again, we see that yes, our number of bedrooms is now set to 6 and our number of beds is now set to 8. So we are in good shape. Let's return back to the updateOne documentation. One of the options you can choose to pass to updateOne is upsert. Upsert is a handy feature that allows you to update a document if it exists or insert a document if it does not. For example, let's say you wanted to ensure that an Airbnb listing with a particular name had a certain number of bedrooms and bathrooms. Without upsert, you'd use findOne to check if the document existed. If the document did exist, you'd use updateOne to update the document. If the document did not exist, you'd use insertOne to create the document. When you use upsert, you can combine all of that functionality into a single command. So let's try it out. Let's return to our code editor and create a new asynchronous function called upsert listing by name. Now this function is really going to look pretty similar to the update listing by name function. So we'll have identical parameters here. We'll have a client, a name of a listing we want to update, and then the updated listing. Now I'm actually going to copy and paste this query from our update listing by name function into this new upsert listing by name function. Because that's what great developers do, right? We copy and paste. Okay, so the one key difference here is we're going to add an extra optional parameter to updateOne. And we're just going to say upsert is set equal to true. And we're good to go. Now our logging is going to look a little different here. So the first thing we'll want to do is indicate how many documents matched our criteria. So we'll log the result.matched count, documents matched the query criteria. When we use upsert, we can check the result.upserted count. And this upserted count indicates how many documents were inserted. So we can say console.log one document was inserted with the ID result.upserted ID, and we'll grab the underscore ID out of that. If we don't have any upserted documents, we'll just say console.log our result.modified count documents were updated. All right, so let's try this out. Let's head back up to the top of our main function. I'm going to get rid of this findOne listing by name. Let's say we aren't sure if a listing named Cozy Cottage is in our collection, or maybe it does exist, but it might hold old data. Either way, we want to ensure that the listing that exists in our collection has the most up-to-date data. So to help us see what's happening here, let's start out by calling findListingByName. We'll pass a client, and then the name of our listing is Cozy Cottage. Now let's call upsertListingByName. So we'll pass our client the name of the listing we want to upsert, so we'll call it Cozy Cottage. Then we'll pass the document that we want to set, so we'll set the name to Cozy Cottage, the number of bedrooms to 2, and the number of bathrooms to 1. So let's save that, and then let's run it. All right, so we can tell from our output that there was no document in our collection with the name Cozy Cottage. So when we went to do our upsert, we can see that no documents match the query criteria, so one document was inserted, and it prints out the ID for us. So let's say we learn more information about our Cozy Cottage, and we want to set the number of beds to 2. So again, we can use upsertListingByName, and we can set the number of beds to 2. So if I run our script again, we were able to find a document with the name Cozy Cottage. So when we ran our upsert, one document matched the query criteria and one document was updated. Sometimes you'll want to update more than one document at a time. In this case, you can use collections updateMany. Like updateOne, updateMany requires that you pass a filter of type object and an update of type object. You can choose to include options of type object as well. So you can see here you do have the upsert option if you'd like to use it. So let's say we want to ensure that every document has a field named property type. So let's head back to our code editor and create a new asynchronous function called updateAllListings to have property type. We'll only have one parameter for this function, and that will be our Mongo client that we'll call client. So we know we want to use collections updateMany. So just as we have with all of our other queries today, we're going to go ahead and start by calling client.db, access our sample Airbnb database, .collection, access our listings and reviews collection, .updateMany. So the first parameter we want to send over is our filter. So we want to search for all documents where the property type does not exist. So we'll use the $exists query operator, and we'll check for it to be false. The next thing we want to do is indicate what we want to update. So we'll say $set. We want to set the property type to be unknown. So really, this is not that helpful. We're just making sure that every single document has a property type. If we don't know what it is, we're just saying set it to unknown, call it good enough. All right, this is going to return a promise. So as always, we're going to use that await keyword to prevent us from moving on until that has come back. And then let's set these results to a constant called result. So just to be helpful, let's log what happened. So let's say console.log result.matchedCount documents matched the query criteria. And then let's also print out how many documents were actually updated. So now we're ready to call this function. Let's go back up to the top in our main function. We'll remove these calls to find a listing and upsert it, and we're going to replace it with a call to our new function, update all listings to have property type. And the only parameter we have to send over is the client. So we'll save it, and then let's run the script. So here we can see 4 documents matched our query criteria and 4 documents were updated. So now all of our documents will have the property type field. Documents that did not previously have it will have property type set to unknown, and the documents that already had property type set will remain as they were. So now you know the basics of how to update a single document, how to update many documents, and how to use upsert in conjunction with either of those. Let's move on to the last of the CRUD operations, delete. Now if we return back to the collection API's documentation, we can see that collection has a function called deleteOne. DeleteOne has one required parameter, and that is a filter of type object. The filter is used to select the document to delete. You can think of the filter as essentially the same as the query param we used in findOne and the filter param we used in updateOne. You can include 0 properties in the filter to search for all the documents in the collection, or you can include 1 or more properties to narrow your search. Just like we saw with findOne and updateOne, deleteOne will delete the first document that matches the given query. Even if more than one document matches the query, only one document will be deleted. Let's say we want to delete an Airbnb listing with a particular name. So we can use deleteOne to achieve this. So let's head back to our code editor. We can write an asynchronous function called deleteListingByName. This function will have 2 parameters. First up is always a Mongo client. We'll call it client. And then a string called nameOfListing. So we'll know what to delete. Just as we have with all of our other functions, we're going to access our collection. So we'll say client.db sample Airbnb.collection listings and reviews. And now we're ready to delete one. So we can call .deleteOne. We want to delete the document where the name is equal to that nameOfListing param. DeleteOne will return a promise, so we'll use the await keyword to wait for it to come back. Let's assign these results to a constant named result. We could be done here, but let's choose to log what happened. So we can say console.log result.deletedCount documents were deleted. And that's all we got to do. So let's try this out. Let's head back up to our main function. And we'll replace this call to do an update with our call to delete. So we'll say deleteListingByName. We'll pass our client, and then let's delete that cozy cottage listing that we've been working with. So I will save that, and let's run our script. All right, and we can see one document was successfully deleted. We're in good shape. Now sometimes you're going to want to delete more than one document at a time. In that case, you can use collections deleteMany. So like deleteOne, deleteMany requires that you pass a filter of type object. Let's say we want to remove documents that have not been updated recently. To do that, we can call deleteMany with a filter that searches for documents that were scraped prior to a particular date. So let's return back to our code editor, and we'll write a new asynchronous function called deleteListingsScrapedBeforeDate. This function will have 2 parameters, as always, a Mongo client, and then the date that we want to check if listings were scraped before. So let's start writing our query. We'll access our client, the database called sample Airbnb, the collection called listings and reviews, and then we'll call deleteMany. So inside of deleteMany, we need to include our filter. So we want to check the last scraped field. And we'll search for documents with dates that are less than, which means before, the date that we received as our function parameter. deleteMany will return a promise, so we'll use the await keyword. And let's assign those results to a constant named result. As always, let's add a logging statement just to tell us what's going on. So let's check the result.deleted count. So we know how many documents actually were deleted as a part of this query. Let's say we want to delete listings that were scraped prior to February 15th of 2019. So we can head back up to our main function. And instead of calling delete listings by name, let's call delete listings scraped before date. We'll pass the client, and then we'll create a new JavaScript date for 2019, February 15th. Now let's try this out. We can see 606 documents were deleted as a result of calling deleteMany. Let's recap. Today we were able to get connected to a MongoDB database using Node.js. Then we worked through how to perform each of the 4 CRUD operations: create, read, update, and delete. Now today we really just scratched the surface of how to use MongoDB and Node.js together. Be on the lookout for future videos and blog posts where I'll walk you through more advanced topics, things like how to use the aggregation framework, how to use change streams, and how to use transactions. Now, if you want to dive deeper, I highly encourage you to check out MongoDB University. They have a free course specifically for JavaScript developers. Now, what makes MongoDB University so great is they will walk you through topics step by step. They'll provide you with hands-on coding exercises so you can try to apply the topics yourself. And they also have quizzes to help you check your understanding. And did I mention that they're free? Okay, so I will drop a link below for the JavaScript course. So thank you so much for watching. I hope you enjoy using MongoDB and Node.js together.